We've been working our way through the 2017 free response questions, and we've made it to number 6. So if you've been following that playlist and you've been working through questions 1 through 5, well, first of all, congratulations. And I'll tell you what, we've saved the best for last. This is an awesome question. So take a look at this, Bear. We've really got 3 functions to play with here today. We've got function G that's presented in a tabular fashion. Function H is presented in a graphical fashion, and function F is presented in an analytical fashion here as the equation. So we're going to get really good at working with and interpreting and manipulating all 3 styles of functions, no matter how they are presented to us. And the first thing we're going to try to find is the slope of the line tangent to the graph of F at pi. So we're going to try to derive this function right here, and we're going to get some really nice chain rule cooking here. So I'm thinking f prime of x is going to be, let's see, I'm going to go negative sine of 2x and then multiply that by 2. So you've got, we're deriving the outer function, keeping the inner function as 2x, and then multiplying that by the derivative of that inner function. Plus, we're going to derive e to the sine x, which is like e to the u multiplied by the derivative of u itself. So what I'm going to try to do is substitute a pi into those. And we're going to be tight on room, but I think we're going to make it happen. So I got negative sine of 2 pi, all multiplied by 2, plus e to the sine of pi power times the cosine of pi. Now, the good news is the sine of 2 pi is 0, so that kind of wipes out this entire side of the equation, or half of that side. Let's see, e to the 0, because sine of pi is 0, so e to the 0 is 1, cosine of pi is negative 1, so my final answer is negative 1. I tell you what, that's about the hardest part of this question, just about. So let's jump into B. Now, K is defined as the composition H of f of x. So to derive K, I'm going to use some great chain rule. Derive the outer function, keep the inner function, multiply by the derivative of the inner function. Let's evaluate this bear at pi. H prime of f of pi times f prime of pi. Now, we're going to have to go back and peek. I don't think we've evaluated f of pi yet, so let's go back and peek here. So if I plug a pi in right here, cosine of 2 pi is 1, and e to the 0 is 1, so I think that's going to make a 2. Let's go substitute a 2. So let's go h prime of 2 times, now this bear we have evaluated, that's our previous answer. And the good news is, here's the approach that they're going to use in grading these. You might have missed A, by a careless mistake, and you did not get the negative 1 that I got. But as long as you take your answer to part A and import it right here, you have a chance to get full credit on part B. Now this h prime of 2 is going to be the slope of h at 2. And so I'm looking, let's see, here's 2. So the slope right there looks like it's negative 1/3. So let's say negative 1/3 multiplied by negative 1 makes a positive 1/3. Ding, 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 ding. Okay, M is defined as the product. The product. We've got g of 2x multiplied by h of x. So let's say the derivative of M using the product rule is going to be the first function multiplied by the derivative of the second function plus the second function multiplied by the derivative of the first function. And don't forget to use your chain rule there. Okay, so we've got, again, this in and of itself is a little composition, g being your outer function, negative 2x being your inner function. So make sure we're using chain rule to get the appropriate derivative right there. Now I think we can evaluate m prime of 2. And let's see, that's going to make g of negative 4 multiplied by h prime of 2. We've got to do h of 2. And then we've got to do g prime of, make sure our prime's there, negative 4 multiplied by negative 2. So who do we already know? I think we're going to have to scoot up to that table to get g of negative 4. We're doing a lot of scooting here. And I think that's going to be 5. Okay. So let's do 5. Whoops. So we've got a 5 here. And then h prime of 2 we already found to be negative 1/3 from the previous example. Now h of 2, let's go take a look at h of 2. Now, let's see. So we start at the origin, and that line segment has a slope of negative 1/3. So this, we're going to go negative 1/3, negative 2/3, and negative 3/3. So negative 2/3 is the value of h of 2 itself. I don't think we have to do any more work than just looking at it like we did right there. So negative 2/3. G prime of negative 4 from that table is negative 1. Let's see, negative 5/3 minus 4/3 is going to make negative 9/3. Boom, negative 3. How about that? Final answer, negative 3. All right. I think this last part, D, is the least computational part, and it is all about the mean value theorem. And basically, we're going to try to prove that the average rate of change of G over the set interval is equal to negative 4. And again, if you've watched it, if you've been following some of our other videos in the channel, we're always saying if we're taking the values of G that are in that table and we're using those values to try to prove the existence of a G prime value, then that's our mean value theorem. The first thing we want to just clarify is G is differentiable, they said, which is going to imply that G is continuous over that closed interval from negative 5 to negative 3. And that basically means like we have permission to go forward and apply the mean value theorem. So I'm going to take a look at G of negative 3 minus G of negative 5 all over negative 3 minus negative 5. Now, we're going to read the values off of that table. So let's scoot up and just make sure we grab the right ones. Let's see, who do we want to use here? G of, let's see, negative 3, G of negative 5. So 2 minus 10. Let's see if we can do 2 minus 10 there. 2 minus 10. On the bottom, it looks like I'm getting a 2. Negative 8 divided by 2, whoop, is negative 4. Hey, that's fantastic. Okay, let's see if I can flip the Chromebook around, and let's see if we can try to type what our sentence is going to look like here. I'm going to say, therefore, by the mean value theorem, there must exist at least one value of C. Okay, now this particular C that we're referring to lives within the interval between negative 5 and 3. And negative 5 is less than C is less than negative 3. Notice the less than signs. We do not want less than or equal signs there, such that G prime of C equals negative 4. So again, it's an existence theorem. We're not telling them exactly what the value of C is. We're just saying there is a C. It does exist somewhere within that interval, negative 5 to negative 3, such that the instantaneous slope is going to be negative 4. Ladies and gentlemen, that's all there is to this question. What a great packet. If you missed any of those 2017 questions, don't be afraid to go find the playlist, backtracks. There's some other great ones tucked in there. And if this channel or if this video was helpful at all, we'd really appreciate it if you hit that subscribe and the like button down below and share this with your friends. We're going to get everybody revved up for this AP exam, and we're going to dance in the streets when we get our 5s. All right? Have a great night.